The first question, physical quantities can be either a scalar quantity. A scalar quantity means it will have a magnitude, it will have a unit, but it does not have any direction. Where vector quantity means it will have a magnitude, unit, as well as direction. So which one is a scalar quantity? When we check power, in this, either power will be there or work done. But when we check work done is not a vector quantity. This is a weight is a vector, so D is the right answer. The unit of a viscosity of a fluid may be Pascal second. Which of the following expression is as Pascal second in base unit? Look, Pascal itself is Newton per meter square. And what about Newton? Newton itself, it is kilogram meter per second square. So this is Newton, and this part is a Newton. Then meter square is there, divided by meter square, and then it multiplied by second. So when I simplify this second will cancel with one of the square, meter will cancel with this. So it will be kilogram, second, and meter. And when we further simplify, it will be kilogram, meter inverse, second inverse. So kilogram, meter inverse, second inverse. So C will be the right answer. A material undergo a significant plastic deformation under compressions. So we did this same type of question. Whenever object can deform under compression, it is called malleable. And if object can deform under tensile force, we call that as a ductile. Brittle means a small amount of force can break the object, that is called brittle. So this is not a brittle. Two options are there. Even what is the meaning of tough? Tough means object can undergo a large plastic deformation before breaking. So it can be like it is before breaking, it does not break. But here they did not mention anything related to breaking. That's why we cannot identify whether it is tough. So either ductile or malleable. Ductile is when tensile force is there, force is needed to stretch the object. And malleable is when force is needed to compress the object, like deform under compression. So that's why C is the right answer for this. The manufacturer of a car claimed that the car accelerate from rest to 30 meters per second in 7.5. What is the average acceleration of a car over this period? So how we can work out the average acceleration of a car over this period? So initial velocity is 0, final velocity is 30, the time is 7.5. So acceleration is change in velocity, 30 minus 0 divided by 7.5. So it will be 30 divided by 7.5, and 30 divided by 7.5 is 4 meters per second square. So C will be the right answer. P spheres P, Q, and R, which are all having a same mass, are lifted from the ground and suspended from a rigid support. The greatest change in the gravitational potential energy. So how we can work out the greatest change in a gravitational potential energy? Basically, the one which is raised to a greater height, like which changes, the change in the center of the mass is greater, that will have a greatest potential energy. So if I draw a same size P, this will be P, Q, and then R. And whenever we are calculating a potential energy, gravitational potential energy, we consider the distance moved by center of the mass. So center of mass of P is here, for Q it is here, for R it is here. Here the center of mass of P, center of mass of Q, and center of mass of R. So when we are moving them to or suspended them, so this one is distance moved by P, this one is distance moved by Q, and this one is distance moved by R. So you can clearly see the distance that when we measure the length, you will find that the distance moved by P and the distance moved by Q is same, but for R it is a shorter distance moved, so which is having the greatest gravitational potential energy seen in sphere. So that is for P and Q. So B is the right answer. So whenever we calculate the gravitational potential energy, we always measure the distance from the center. And the one which shows a greater change in height will have a greater gravitational potential energy. The graph shows the extension of a spring varies when the force F is applied. Select expression that best describe the work done in extending the spring. So work done is area under the graph. And which side area, like example, remember if force is on y-axis and extension on x-axis, so this area under the graph will give us the work done. But if it is opposite, the extension on y-axis and force on x-axis, so this area will give us the work done. And remember, if it is making a triangle, then it is the work done is area under the graph, or it will be half base into height. So if I want to calculate, because extension on y-axis, force on x-axis, so this area. And if it was a straight line, then what about the area of this part? It will be half base into height. So it will be half force F1 and extension x1. So half F1 into x1. But because it is more than that, this extra part is there. You can see this extra part is there. So it means the work done is more than half F1 into x1. So that's why D is the right answer. So area under the graph will give us the work done on the spring or work done by the spring. But remember, whenever you draw a perpendicular, you should draw a perpendicular on x-axis, on extension axis, to work out the area under the graph. And as you can see, this area exceed more than the area of the triangle. That's why we are saying that the work done will be half. Work done will be greater than half F1 into x1. If it was a straight line, then it will be half F1 into x1. And if it was other way around, and this will be the area. So now this area will be less than the triangle. So it will be half F1 into x1. Question 7, the displacement and time graph for an object is shown. Which of the following statement is correct? So displacement time graph, what slope represent? The slope represent the velocity. So the slope represent velocity. Here slope is decreasing, it means the velocity is decreasing. If velocity is decreasing, it means the force is opposing the motion. Like if object is moving towards the right hand side, but the force try to resist the motion, that's why the object is slowing down. So there is a decreasing resultant force We cannot say decreasing resultant force. So we can say there is a resultant force acting on the object. So you can see the option C, there is a resultant force acting on the object opposite to the direction of motion. How we conclude, how we identify it is opposite to direction of motion because the velocity is decreasing, and velocity can only decrease if the force is opposite to the direction of the motion. Then question 8 and 9 refers to information. A box is placed on the table. The box and table both are stationary, both are not moving. The diagram shows the forces acting on the box and on the table. Which pair are equal in magnitude according to Newton pair forces, according to Newton's first law? So according to Newton's first law, if an object is at rest, it will remain at rest. If an object is moving, it will continue to move until unbalanced force act on it. So as a result, what is happening? As you can see, if we work out which one could be a right expression, because the box is stationary. So according to Newton's first law, I can say there is no resultant force. If there is no resultant force, the upward force should be equal to downward force. So upward force is NB and the downward force is WB. Or I can say NB minus WB should be equal to 0. Or when I write for table, when we are writing for table, as a table is also stationary, then there should be, like example, the weight of the table is downward, the force of the box on the table. But this is always this reference to the, they did not mention any force related to the floor, so we cannot use this for relation. That's why for box, there should be no resultant force according to Newton's first law. Then we want to identify which pair are equal in magnitude and opposite in direction. So Newton pair forces, the downward force by the box should be equal to upward force on the box. So when we check the pair force here, according to Newton pair force, the box will apply force on the table, and the table will apply force on the box, but in opposite direction. That is making a Newton pair force. So force of the box on the table, that is this, should be equal to force of the table on the box. They will make a Newton pair forces. So Ft and Nb will make a Newton pair force. So option which include Ft and Nb, that is A. So that's why A is the right answer. So because action and reaction forces are equal in magnitude but opposite in direction. So if we place a bottle on the table, the bottle is applying a downward force on the table. As a result, the table is applying an upward force on the box. And the last question. A student investigates the Hooke's law using the equipment and each additional load is added. The new position of a marker is an extension is recorded. The investigation was repeated with an additional identical spring for a given applied force. Which of the following statement is correct? Now what happened? We connect springs side by side. Look here, weight is W, here also weight is W. And this weight example causing an extension E. But when springs are side by side, each spring will experience a force W by 2. This will also experience a force W by 2. We are applying force W, but each spring will not experience W, it will experience W by 2. So we have the formula. So if force is half, so extension will also be half. But we are applying the same force, so F is equals to Kx. Force is equals to spring constant multiplied by extension. So if the extension is half, extension is divided by 2, what should happen to spring constant? It should be double, because we should get the same value of the force. As I mentioned, for a same load, so when we are keeping the load same, we are not changing a load. Here is same as load here. So if we double the, if we connect two springs side by side, so the weight will divide between the two and extension will be half. So for the same force, if extension is half, it means the spring constant is double. So which expression? Extension is half and the spring constant is double, because the force is constant. So C is the right answer for this. So this was June 2018, Unit 1.